Hello guys, welcome back to the stream. So what we'll be doing today is firstly writing test for the pool, worker pool. So last time in the worker pool, what I did was, let me tell you, we go to worker pool. So I wrote the worker pool to not depend on the queue itself, but add queue to the worker pool in the basis like this is. In the prior context, the worker pool only relied on one queue, but now it can have multiple queues, and then it does round robin scheduling based on our queue snapshot, which is like this. It takes one queue at a time and checks if it is ready and all that, which is done here. And wait for work and all that is just simple functions. I also need to clean this up, but we'll do this later. Firstly, what I'll do is I'll write a small test to check the behavior of our worker pool. The test I need to do is that when I add a queue before starting the worker pool, it should not it should not start working. Okay, so the worker pool should only start working after I use the function which is start, which is here. Only after start the worker pool should start. Adding the queue does not affect the worker pool. I need this test because here we are using wake worker call. So wake worker can be tricky to go around. So we need a test to verify the behavior. So let me write a small test. It will be a smaller test. The major test will be coming this Sunday. Okay. So on Sunday I'll do all the testing. For now, it will be a smaller test. What I will do is I'll create a small queue interface, a small struct, which is let's say it counting queue, which will count how many times DQ happened, because we are only concerned about DQ, because the worker pool does one thing, that's DQ. So what I'll do is name. It will have a name, which is string, and a count. Now the count should not be like we should call it DQ. The count should not be synchronous. If it is synchronous, that can cause issues. So what I'll do is I'll use the atomic package, and inside the atomic package I'll use int64 to store the count of how many times DQ happened. So to make it like a queue, I have to implement the interface of queue, which is enqueue, dequeue, length, and name. So what I'll do is I'll write some functions for the struct, which is a let's speed it up by counting queue, and this is enqueue, which follows the queue as well. Let me just copy it from here. 2.2, we have these functions. I need this one first. See what I'll do is paste it here so that I don't misjudge the what I call it, misjudge the what I should say, misjudge the spellings here. So this is what it does. Inside it I'll return nil, because it doesn't matter to us. The only function that does matter to us is DQ. What I'll do is copy this DQ. It will take a context, and it will give us a copy this one, paste this here. So this is what we need. What it will do is it will just increase the number of queue added, queue dequeued. So what I'll do is use the add function, which adds a delta into our atomic int. So it adds 1. So whenever dq is called by any worker, 1 will be added and dq value will shift to 1. We don't concern about the errors here, so I'll return nil and errors dot new. Queue is empty. The error does not concern us, so this is all we need. Now for one more thing, we need 2 more functions, which are like function or queue, star, counting queue, and it will follow the length. It will return 0 for now. We don't care about it either. Lastly, the function we need is a name. It will return the name. For now, we will return q.name. Yep, because we have the struct defined as such. So we can do is name. For returning the name, I'll return q.name. And for name, should be like this. Or what I can do is, I didn't give the return should. Yeah, after returning this, the queue has the counting queue has implemented the queue, so now it will behave as a queue. So now I can write the test. The test is simple. It will check if adding a queue starts the worker. If it doesn't, then we pass the test. If it does, then we fail the test and we have to check our code. So let me write the test. Test. Okay, test. I need to import the testing package too. I'll import it later, but for now, add queue, the name of the test. Does not start worker before start called, something like this. So this is our test name. We'll use t, which is a testing dot t type. So we need this, and that's all we need. What I'll do is I'll spawn a new worker pool. New worker pool. It needs parent context, so I'll pass the context dot background. It also needs a job store. Don't concern with it. Registry. No need to concern with it. Retry engine. No need to concern with it. And the workers, I'll pass them to for now. This is for just test environment. So what I'll do is I'll create a new queue, which is % counting queue. Okay, we need to give it a name. Let's name it default, or better name it test. Okay, so this is all it needed. Now what I'll do is pool dot add queue. So I'll try to add a queue. So the naming is not good. It should be add queue. It should be where it is add queue, because at a time we are using just one to add the queue. The server, did we do? No, we didn't do. So this was fine. So pool dot add queue. What I'll do is I'll make the workers sleep for about make the process sleep for about 25 milliseconds, and after that I'll check if the DQ has increased. Time dot millisecond. Now I will check if the DQ value has increased. If got from q dot dq dot load, to load the atomic value, we need this function. So if the value we got is greater than um, 0 or is not equal to 0, that will be much better. If it is not equal to 0, what I'll do is I'll give it an error f, t dot error f. Instead of error f, I should do is t dot fatal f. So it is a fatal error. So what I'll do is expected no dq eu dq. What is the spelling, man? dq this one. Attempt expected no dq attempt before start call, and we got percent d attempts. The percent d is our drop, and that's all we need to check here. Next thing we need to do is check if our worker pool dequeues after the start call. There can be an issue with our dequeue, so we have to check that too. So what I'll do is t.cleanup function. The cleanup function will be our pool.stop. Stop. It will stop the pool. Sorry, we need to pass the reference. We don't need to call the function here. We need to pass the reference pool.stop, and next thing we will do is for now what I'll do is I'll have a deadline. The deadline will be such that if workers don't dequeue within the set deadline, we will call that the workers didn't dequeue and fill the test. So what I'll do is time.now.add. What I'll add is, let's give it 250 milliseconds. There can be some issues on that, so let's give time.milliseconds 250. If in 250 milliseconds the worker did not respond, it means there is an error. So what I'll do is I'll check the value of dq for q.dq.load. I'll check it in loop. If it is equal to 0, and time is before deadline. Dot now dot before deadline. If the time is before deadline, then we will make the worker sleep for 5 seconds, 5 milliseconds. Time dot sleep, so that we don't call this too much. 5 milliseconds. Okay. Now we'll check after this has been done, this block has been done. If got, we can get q.dq.load. If got is equal to 0. If it is equals to 0, then it's an error and we have to return that. So it is a fatal error. So it should be expected dq attempt. Now looking at that, I think there is a mistake there. Attempt after start call. That's all we need here. So fatal F is not needed, and this is all we need. I think the test is done. Let's run the test. What I'll do is do this and go test dot There's one test which gave it okay. I should do is go test controller slash okay. Internal software is not in std internals. Okay, GoTaskQ internal slash worker. What should I do is I should cd do internal slash worker and then run go test. It passed, so we can also check the workflow settings, and it ran this test. It took 0.03 seconds and it passed after that. So our test is working fine, so we can call it good add queue function regardless. Now let's go to the next part. Next thing I need to do is I need to what do I need to do? I need to change the behavior of handle failure. I need to change the behavior of retry engine too. I checked that retry engine also relied on queue. I should not allow this to happen. It shouldn't depend on the queue, but it should work independently without any queue context. So what I'll do is I'll remove these from here, the queue references from here, and inside the handle failure I'll pass along the queue. With the job, a queue will also be passed. Queue is the type of queue.queue. That will make it work. What I'll need to do is here I need to pass queue equals to queue.queue, and now what I'll need to do is instead of engine.queue I'll check for queue and here for queue.name. Next thing I need to do is check it context not found. This is okay. Increase jobs required. Here I also need to pass along queue. Here I think one more check is needed. That is, we'll check if here queue is nil. If queue not equals to nil, then only we will execute it. Otherwise, this will panic and cause issues. If queue is not equals to nil, I'll check the error. If error is not equals to nil, then we will say handle failure this. If queue is equal to nil, then what we'll do is we'll fmg.printf. Okay, what will printf is handle failure. What happened? Queue is nil. Also cannot enqueue job with ID, which is ID. We will pass along the j.id. That's all we need from here. Next thing we need to do is this is all we need to change in our retry engine. One thing I need to change also is the calling of retry engine, which is done. Is the retry engine being called? Check. Here is it called is handle failure. Yep. Here handle failure is being called. So what I'll do is pass along the queue. If I'm not wrong, yep. I'm passing along the queue. It is handling the failure, updating the status, And one more thing I need to do is here we will also need to pass along the queue. And what are the other places we have used handle failure? This is the one more place we need to pass along the queue. So what I'll do is pass along the queue, and that's all we need. Any other changes we need? Let me check it. It only takes a reference to the retry engine, so it's not an issue. I think everything is good to me. Looks good to me. One thing I need to do also is here in the new retry engine, instead of passing main queue, I'll keep it as it. And this should work. Before worker pool dot start, one thing I need to do is worker pool dot add queue. We'll add the main queue and then start the queue. That's all I think for here. Next thing I need to do. Now everything I think is wired up to each other. We are adding a queue. We can work with multiple queues, but still in the API part, as I remember, we had created a API to add create a new queue. What it does is it only registers the queue, but it never adds the queue to the worker pool. So what I'll do is I'll create a small interface that will just implement the add queue function. So what I'll do is type let's call it a registrar. What it does is it only implements the add queue interface. Add queue interface. And it takes a queue. This is the type of queue queue, which is a type of queue. So it implements the add queue interface, which is called here, as we can see where it is here. So it will work regardless. So what I'll do is I'll go to the after calling this, I'll change the handler. So what I'll do is I'll change the handler whenever a new queue is added. Actually, one thing I noticed here is it never returned up to the error, which is an issue. And next thing, after registering the queue, what I'll do is I'll add the queue to the worker pool. Now, how will our server know that who is the registrar? So we need to pass along a registrar to our server. So the registrar I'll pass as a worker pool through main, and then I'll map it to the server using our implementation. Let me just write it down, then I think you can understand much better. In main.go, we create a worker pool. So while creating a new server, I will also pass the worker pool. Since the worker pool has a function, add queue, it can work as a registrar. So I'll add it to the server.go. It will take a registrar, which is a type of queue dot registrar. Okay, so it's an interface. So whenever we pass a worker pool, it will work fine. What we'll do is we will call the registrar. We will also pass along the registrar here. This is a queue dot registrar, and here I'll pass along registrar equals to registrar. That's all we need here. So it's a queue.registrar and that's a queue register. I think that will work fine. Queue factory registrar has been passed. Okay. Now, since registrar is passed here, I also need handlers to have the registrar. So what I'll do is f dot registrar. I'll pass this to the handler helper. So handler helper should also take a registrar. Registrar will be q dot. I can call it registrar. Yep. And it will take a registrar, which is registrar, and this is registrar equals to registrar. This might look like tedious words, but sometimes we have to do this. So what I'll do is I'll check if there is an error in adding the queue. If error, so if h dot registrar dot add queue will pass along the queue. So what is the queue? This is the queue. We need to pass it along. Okay. So this is what we need to do. Before that, we need to check if the registrar is not nil. If h dot registrar is not nil, then only we will do this. And let's format this. Let's remove this. This looks good to me, and I think this is good to. Next thing I need to do is, as I told you yesterday, we have to do a lot of small things today. So what I need to do is I'll need to have a test to check this behavior. The behavior I need to check is firstly, if the creating a new queue adds star, I need to check that if registration succeeds or fails, then only registrar works. If registration fails, then registrar should fail. If registration succeeds, then registrar should succeed. So let me write a small test here too. Q underscore test dot go. So it will be package handlers. Okay. So what I'll need is I'll need a registrar. The registrar has only one method. How will I check if a queue has been added? I'll check it by the number of queues currently there are in the register. So let me just write the implementation. I think you can understand while I write it. Let's write it. What I do is I have a package handlers. First thing I do is I'll type recording register, record register, or a recording register, because it records how many queues have been added. It's a struct, and it will have a count. It is simply int, because this is network call, this is not a synchronous. So under synchronous behavior, like the pool worker was. So what I need to do is one, I'll implement the add queue on our recording register. Add queue, it takes a queue of type queue.queue dot queue, and what it does is it will just increase the count out plus plus. That's all we need from it. Next thing we need to do is to check the test. We need a request with the Q param. So with a Q name. So what I'll do is I'll create a helper function that creates a request. So func request 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 with Q param. So it will be a request that will have a Q param. So it will have a name, string, and it will return as a HTTP dot request. So this request will be used to call to check the behavior. So the request will be we'll use the HTTP test module package to create a new request. The method will be HTTP method dot method HTTP dot method post. It will be a post method on our slash q ue slash plus name, the name passed along, and it will have nil body. So it doesn't have a body, it only has a parameter like this, request parameter like this. So we need a route context which is she dot new route context. So we'll add the parameter to our route context, URL params dot add. What we'll add is name, name. So this is a key value where we are adding the name as a name into our route context. So we'll return the request with context, right? Not with context. The context will be so the context I need to use is, and let's define a helper function to get the context. Func context with a route. So what I'll do is I'll have a request which is request. It will take a request and a route context which will be star g dot context type, and it will give us a context. So what it does is it creates a context out of our context dot context dot context. It takes the context in our request and merges them to create a new context. So what I'll do is return context dot with value. The value, the parent context is our dot context, and the key is she dot route context key. So she exposes the route context key to store the request context. So we will have the key here, and the value will be our route context as this, and then it merges all them to create a new context, and we will use it here. So we will call this context with the route and pass along the request. The request is REQ, and the route context is route CTS. And I think our helper functions are done. So let's create the function to test. Our test will be create new queue. It is for creating a new queue. Okay, so what I'll do is let's write the test. First test I need two subtests, which is t dot okay, testing package is not imported. I have to import it. T dot run. I'll run. The name should be add queue to register after successful registration. Something like that. Add queue to queue to register after successful registration. So it will check if we can add a queue to the register after a successful registration. So what I'll do is I'll have a fun test, and the test will create a manager, which will our queue dot new manager, new queue manager, and registrar will be our the registrar we created above, which is this is struct, and ampersand recording registrar, and we will call this here with empty value, so the count will be initiated to 0 itself. And handler, now we'll have to create a handler. Give me a second, guys, I have to attend a call. Hello. हाँ जी मार ये आधा दिन नहीं हुआ अभी, पता नहीं कौन कॉल कर रहा है मेरे को। और क्या यार, मेरे को यहाँ पे मैं वो कर रहा था, स्ट्रीमिंग कर रहा हूँ अभी मैं काम की अपने, तब मैं बोला पता नहीं कौन इम्पोर्टेंट कॉल कर रहा है मेरे को। बोलो जल्दी, मैं वो यूट्यूब पे लाइव हूँ मैं। हाँ, मैं अपना पढ़ता हूँ साथ में लाइव। हाँ जी, ठीक है। Sorry for the interruption, there was some important call. Next thing what I'll do is I'll create a new handler. Handler will be new. The new it takes a job store, which will be nil, we don't concern it. Queue manager we have created above. ID generator, which is nil, we don't concern about this in our test. DL store is nil. This is only a unit test, not an integration test, so let's do so. Factory, so for factory we need to queue dot new factory, we need to create a new factory. So for the test I'll create a new memory factory. Okay, and lastly we need a register, which is our register. This is all we need. So what I'll do now is I'll have a request recorder, so which will be http test dot new recorder. So let me just write it, test dot new what is this, sorry, the test is written as this, dot new recorder. Alright, so I'll have a new recorder that will record the request going forward. So I'll create handler dot create new queue. I'll call that request, I'll call that function with the request recorder, and our request with context that we create, a request with queue parameter that we created above. The name I will pass along is XYZ, something like XYZ. Okay, so it will register XYZ first, then try to add it to the registrar. It should succeed. So for that, let's go and check different conditions. If rr.code, if the code is not equals to, is not equals to http dot status created. As you can see at the final, we were passing http dot status created. So if it's not equal to that, then that means we failed, and we should return. So we will throw an error like t.fatalf expected status. As you know, that's integer value %d. Got %d. That's all we need. http expected http dot status created, and we got rr.code. That's all we need. Next thing, we need to check if registrar count is not equals to 1. That means registrar count, it should only increase by 1, or if it is 0 or any other value, that means the registrar failed to. Okay, so let me just write a small if registrar dot count is not equals to 1. Not equals to 1. Sorry. What am I doing? 1. Then what I'll do is, what I will do here is I'll write a error which will be like t.fatalf which will be expected registrar to be called once. So we only expected the registrar to be called once, but got called %d times. So I'll just pass registrar.count. And last thing we need to check is if we can get the emails. If we can get the queue. Then if we can not get the queue, that means queue was not registered. So if we notice on this value, if there is an error while manager dot get the name is XYZ, then if error not equals to nil, then what we will do is we will have a fatal error. We will pass along a fatal which is expected queue to be registered. Expected queue to be registered, and pass along the error we got. That's all we need. One more thing. This is the first error we need to check, and the next error, the next test we need test is t.run. The next test is add queue to register after successful registration. Does not add queue to register. Does not add queue to register after registration fails, or when registration fails. If registration fails, it should not add queue to our registrar. So I'll add a function, the testing function. Again, I'll create a manager and all that. Manager, register, and a handler. Okay, what I'll do is I'll create a manager just like we did above, and I try to register the same queue again, the same queue which is XYZ. So if I try to register the same queue, it should result in an error. If error in manager dot register, the queue name is, the queue is our queue dot new memory queue, which is XYZ. Alright, if we try to register XYZ again, if error is equal to not nil, no, in this not let's see how we do it. Okay, what I'll do now is instead of I'll create a new memory queue on the initiation, and using the create new queue, I'll call XYZ again. If it adds the queue, that means the test fails. So let me write the test. T dot fatal F, which will be register existing queue %v, because it only gives error if we try to register an existing queue. Again, we need a registrar and a handler. Same way we need it. We did above. A registrar like that and a handler like that. Okay, we have this. Next thing we need is a record tester and request recorder and a handler like this. Handler invocation. That's all done. Now, what are we doing is we already have a new memory. We already have a queue named XYZ, but we are also creating a new queue XYZ using our function call. So it should result in a internal server error, and the count should not increase to 0. That's what we are going to test. Let me just copy these two. I'll just finish these. So http dot internal server error status internal server error. It should result in an internal server error, and this should work. Status internal server error. That's all we need. And here, if the count is not equals to 0, so it means we expected register not to be called. But got %d calls. That's much better. And here I should also have got %d calls. Let's try to run these tests. Okay. So what I'll do is cd /back where's the directory? So no, we don't need to do that. Handlers slash. Let me go back. We are internal. Oh, we need to go to API. cd API handlers. We need to go to that will be fine, and go test. That passes the test. in 0.05005 seconds. That means everything is working fine. I think that's all we need from this part. Anything more? I'll write the whole test suite later, but for now, these small tests are fine. And next thing I need to do is to implement the TTL structure as I defined. As I told you last time, after retrying, let me tell you where. After the process fails or the job fails or succeed, after the job succeeds, we will delete the job. After the job completes, we will delete the job, and the delete should not be instant. It should have a TTL. So the TTL will be like the time to live, as in Redis, the time to live, as in memory queue. I'll create my own custom TTL function. So let me write that. What I'll do is I'll change the store behavior. Currently, here's our job store. Currently, the delete function, what it does is it calls the it validates the context and it deletes instantly. But I don't want it to delete instantly. I want a TTL to be passed while creating a what we call a new store. So let me write some code around that. So the TTL will be time dot duration. We need a TTL in memory store and also in our Redis store. It will be TTL and duration. Alright, next thing we need is a new memory store. In the new memory store, what I'll do is I'll take a TTL, but I'll take it as a what we call as not time dot duration. So I'll take it as a argument which even passed if not passed, it will result into 0. So I'll give it complete job TTL. It will be like this: complete job TTL equal to time dot duration 0. The default value will be 0. What I'll do is I'll check if length of TTL is greater than 0. If length of TTL is greater than 0, if it is greater than 0, I'll take the complete job TTL as the first value passed. TTL 0. So why I passed a slice is that if a user gives nothing, it will take the 0 value, which means empty slice. So empty slice will result in complete job TTL to be set to 0. So that is all we need. And last thing we need to do is I have to return TTL equals to complete job TTL. This is what we need to change in our in-memory store, and in our Redis client. What I need to do is I'll simply take a TTL with the Redis client, because the Redis implements time dot duration. Alright. In Redis store, TTL is mandatory. So what I'll do is I'll have a client, Redis client, and a TTL which will be equals to TTL. Let's forget this out. Where is it? It is here, and if we do this like this, and this works fine. Nice. Next thing we need to do is change the delete function in both of the calls. In our in-memory store, the delete function should invoke invoke something like it will create a time dot after function on our job. So let me define it how it will work. So what I'll do is, if error this everything looks good to me up to this point. Instead of deleting job instantly, I'll do is, if our store dot ttl is greater than 0, if ttl is greater than 0, I'll take the current job ID, which will be the current job ID will be store dot job with current ID. I'll take the current job and the reference to current job. So this will work as a reference to my current job. What I'll do is, I'll have a time dot after function on our on this. So the duration will be store dot ttl, and the function we want to invoke is firstly we'll lock the mutex. Secondly, we'll defer for store dot mu dot unlock, and then what I'll do is I'll check if the job is not equal to current. Store dot jobs ID is not equal to current ID. If the current job is not equal to the store the jobs provided by the store, I'll simply return without giving anything, and if it is not, then I will delete. I'll call the delete function over store dot jobs comma the ID. Now what I'll do is, I'll return nil. Now I need to check what is the issue here. Too many arguments in the call after time dot after function. I need to pass along with function. That I need after function or the after call. That's we need. If store.ttl is greater than 0, then this will happen. It will create a time dot after function that will automatically invoke itself after some time and delete the job with the ID. If it is not, then it will do this. And I think everything looks good to me. Next thing we need to do is, in our delete function in our Redis store, instead of calling delete here, I'll call expire. So it will expire after a TTL, which will be store.ttl. And I think this is all we need. Delete, or we can call expire job present as from Redis failed. Alright, so TTL is handled. Now the job will get deleted after some time. One thing I also noticed in the code was the DLQ was setting the queue depth for, as it is, the metrics for our dead queue depth. So let me just get to that. Where is the save never DLQ? Oh, sorry. Here we need to go here. Here in the save method, I was seeing that matrix was set here. Instead of setting the matrix here, what I'll do is I'll set the matrix in the retry engine itself. After the job fails and fails infinitely, I'll set the matrix there, and I'll remove this from here. And is it needed? It is not needed. I'll also remove this. in our retry engine, what I'll do is max retry exceeded. Save that job to engine.store dot update status. After updating the status, before pushing to DLQ, push it to our DLQ. Push it to DLQ is equal to nil. Handle failure DLQ email cannot persist deadlock. After before pushing to DLQ, what I'll do is metrics dot increase jobs that the queue name will be over dot name, so tell us which queue is DLQ telling us the whole idea, which was we were not able to figure out which queue was failing rapidly. So the job type will be right, and metrics of that is fine for here. And one more thing I needed to do is in our binary queue here, this wasn't setting any metrics. So what I'll do is metrics dot increase set queue depth. Yeah, we need to select the queue depth here, which will be instead of calling the length, is queue dot name, and the depth will be queue job dot, and that's all we need here. Everything looks good to me. Next thing we need to do is we need to check that we need to pass along the TTL. For that, what I'll do is I'll change the config so that it also takes a TTL. Complete job TTL. This will be time dot duration. So what I'll do is I'll take complete job TTL OS dot get PNG. This is not needed after when I move the package user, but for now we need it complete job TTL. This will be a key os.get in with this. And I'll convert it into time.duration. What is the issue? Cannot convert value of type string to time.duration. Like will return a string. So what I'll do is what it can do is it can convert duration, time dot duration. How can I convert it? That's the question. I need to check it out. I think looking at it. Is there a way to convert? Let's check it out. We need to have a time dot duration conversion. Time dot duration. No, let me do it. All I can do is env to yep, like this, and paste it here. What's the issue? Not enough arguments to call. if it was, let's have a complete job TTL of 5. So it will use, shouldn't we convert? We shouldn't convert it here. Let's see how max delay is handled. Max delay was handled prior. Where is the max delay? Max delay, max delay, max delay. Max delay, max delay. Time dot duration. So, if I pass int 64 to this, what is taken as it, make it as minutes or seconds. Let's Google it. If I pass time int to time dot duration, will what will it be passed to? Minute. Go passing into time dot passing, it interprets as nanoseconds. So it interprets as nanoseconds. 16 not 16 convert resolution minutes time. Okay, I need to pass the window. Okay. What I will do is, okay, simple. What I will do is, I will pass it as a normal variable. env int. Should I use time dot duration only here? I should use time dot duration only here. Let's use the int here, and the time package will not be, and env to int, I'll call it plus dot get env, that's our key complete dot, that is what we need, and the which will create env, this will create env. Too many are going to go. It should be like this, and 5. So 5 here represents minutes. You should document it. Minutes will be converted in minutes. In minutes. Okay. So I'll take how many minutes the job has to be deleted. So for that, what I will do is, in the new Redis client, I'll pass cfg dot complete job TTL into time dot. This is what I got through my Google, that this is what we need to do. Here this is a new Redis store and a new memory store. During a new memory store, I'll also pass time dot duration cfg dot complete job TTL into time dot minute. Let me ask the AI once before going further. Let's call it here. Is this okay? Let's see. Anything more we need to do? I'll call read file and a single complete family to let the AI do its part. Converting complete memory design is correct and standard. Yes, that expression is correct as long as you minutes which minute. Okay, this is correct. Next thing we need to do is I need to update the example.env for now and hash job key expiration in minutes. Default value is 5. Job key expiration, we said it was complete job TTL. Let's copy it from here and paste it in our env also. So this is what we need. Complete job TTL is 5 and yep, that's all we need. I think everything looks good to me. One thing I need specifically is before shipping the version is a test to verify that the TTL is working. So to verify the TTL is working, I have to write a test on store.code. Let's write a test. What I will do is, let me first check how much time has been left. Let's write a small test file, then we will test the system and close the stream. So on the store.code, I wrote the implementation, so I'll write store underscore test dot go. Okay, it will be package job. That is all. Alright. So two things I need to check. Firstly, that the memory store. The Redis will work fine because it is implemented on itself. So TTL in Redis is fine, but the TTL on our memory store is the main problem. So I'll check the memory store. First thing I'll check is that the memory store retains the job. It should retain the job until TTL is reached. So one test for that, and other test will be to test if the TTL is not there, if the TTL is not passed, it should delete the job instantly. So these are two of the small tests I will do. So let me write one test. Let me import this too. Test memory store delete. Memory store. We are checking the delete function of memory store. There will be two subtests. T.run. First subtest will be retain job until TTL, and the test will be fun. And first it will do is it will take a context, which will be context.background. Sorry, one call. Give me a sec. हाँ बोल. अबे स्ट्रीमिंग कर रहा हूँ, नहीं कर सकता. Sorry for the interruption. Let me pass the context, which is context of background. So one more thing I need is to initialize the store. Store equals to a new memory store with the TTL. Let's give it a TTL of 25. So it will take 25. Let me once verify one thing. The TTL here is fast, like where is the TTL fast? It is fast here. Okay, it will take time dot duration value. So in the main it was passing seconds, but I will pass it 25 dot time dot millisecond. Okay, so this is what we need. For 25 milliseconds it will wait, and a job we need to create a ampersand job. So the job, it should be like this. ID, let's create a job one, doesn't matter much. Type logger, um, status is done. It means job has completed. Now we need to delete the job. If error in our store dot say, yes, we need to pass the context and the job. Then we check for the error. If there is an error, the fatal error, which is save job. I'll write it %v, and that's error. Okay, next thing we need to is delete the job. If error in deleting a job, store.delete. If there is error, yes, change error not equals to nil. If error not equals to nil, we'll pass along t.fatalf, which is delete job, the error we got %v, which is the error. That's all. Here, next thing we need to do is we'll get the job. If we don't get the job, it means the job got deleted instantly. If we got the job, that means the job got deleted instantly. That's what we're going to check. If there is error in store dot get context id and the error not equals to nil, then we will pass along t.fatalf, what will pass along is t.fatalf. Expected job to be retained. It means we didn't get the job, so we expected job to be retained before TTL, and the error we will pass along error. And next thing we need to check is we will sleep for let's say we'll sleep for 75 milliseconds. After that, the job should have been completed. So we'll check. If we still can get the job, that means the job did not get deleted. So let's check. If error, I should copy this. I should paste it here. If error, here what I'll do is I need to check not errors dot is, the error is not job not found. Then expected job to be removed. If the error is not job not found, then we expected job to be removed after TTL. If the error is this, then there is no issue. That means the job got deleted, and that's all we wanted. There's one issue, and the issue. I need to check it out. We'll see it later. What is the one issue that's bugging us? J.id. We need to pass another ID. Yeah. Second test is t.run. The second test we need to check is remove firstly retain job until TTL. So remove job immediately without TTL. Remove job immediately without TTL. If TTL is not given, we'll remove the job immediately. So what we'll do is function, it should be like this. I'll copy from above the main three things, which is this one. Now first thing we need to check is saving the job. Again, copy this. The job is not getting saved, then we need to delete the job. If there is error in deleting the job, then there is an issue. Also like this, the above statement. After that, we will check this one. We'll check this one, but with this one, we'll check this one directly. We don't wait for any time. So instantly, if the error is not equals to error job not found, then this will be expected job to be removed immediately. There. That's all we need. The test is complete. Let's run the test. So let me run the test. CD --back. Where are we? In our job slash. Yeah. Here we need to jump to test. Fail. Expected job to be removed immediately. This test failed. So the job did not get removed immediately. Firstly, let me check if there is an issue with our error. So, test show.get get if the error is not job not found. Just need denote capital F. Expected job to be removed immediately. Now we have to debug this. So let's debug this. What it does is, if store.ttl is greater than 0, if we don't pass anything, one thing. The test was wrong. Sorry, we didn't. We need to not pass anything. Now run the test. Now it's passing. Let's call it the verbose. Way it will pass in 0.08 seconds, and it ran and it passed. So the issue was with test, not with the code. Sorry for that. And with that, I'll say the multi-queue part has been done. So let me create a new binary and test it. Once we test all the things manually, then we can say the version has been shipped. So let me just go build. What am I doing? Oh, sorry. CD --back. I need to do on the global. And now we have a binary. Let's run the binary with the memory part first. GoTaskQ. Okay. In the memory backend, let's do the things. First thing we need to do is curl. We will create a new queue. Let's create a new queue. Okay. We will check the queue names. So what are our handlers? List queues. So the list queue works like we have to pass along /q. So let's pass /q. Sorry, it's not a post request. We need to pass a get request. So we have two queues now, and that's working fine. Now let's create some jobs. So what I'll do is call first a job on our default queue with a delay of 2 seconds. Let's see. It ran and it was completed. Now next a job on our jobs. How is it done? We need a queue name here, and the queue name we passed is XYZ. So it's done, and it should be done right. We can verify last date is 984, and here, yep. So multi-queue instance is also working, and for this memory queue is not getting into a deadlock. So this is working fine. Next thing we need to check is our work with our what we say it, Redis. Firstly, I need to clean up my Redis CLI. Okay, so Redis CLI. I need to flush all and control D. Let's see now. Let's clear everything. Let's GoTaskQ. So now it's using the Redis-based backend. Alright. So let's do one thing. First, let's create queue XYZ. Did it create the queue XYZ? What is the issue? It never posted. Is it running? It is running. Using Redis based backend. This should be like win.go. After where is using Redis based backend. Here it should say using Redis based backend. New worker tool full.go. Text.background. Starting the service and blocking. This was not printed. Why is this not printed? I need to delete this instance, Let's create one more instance of our terminal. Set the entry and /GoTaskQ. Starting the service. So it's starting the service, which is here using Redis based backend. Okay. So in between there's one issue. It's not registering a queue. Okay. Okay, handler registry dot register logger new retry. Actually trying them. Now there is an issue here. New server. If it was a server, hotspot server, then we should have said starting the service and blocking. Why isn't it getting to this part of the code? Firstly, let's try curl again. Firstly, curl. Let's try if the server is working by checking the field to connect to localhost port 8000 after 0 ms could not connect to the server. Why it could not connect to the server? It means server is not running. What can be the issue? Yeah, okay. Everything looks good to me. API server the start is a configuration plus port. Let me grab. Yes, yes, also, yes, okay. Go, not go, that too much clear. Task queue. So a GoTaskQ version is working on code. So let's say 16. What is this? Share code. Develop share code. Oh, so it's the instance of this VS Code instance. Nothing else. And this is a graph. So this is not the issue. This graph 8000. Code 8000 does not return anything. So this is not the issue here. What can be the issue? Let's delete this. Let's delete this. When I call GoTaskQ with in-memory backend, it's working. But when I call set A and when I call GoTaskQ, it is not working. So in between this part, there is some issue that is silently failing. Let's see. After using the Redis backend, it should use Redis too, but use Redis. This was not the issue. It was also not the issue. Not the issue. It should have been failed to close Redis command. This should have not been done. Failed to create. Failed to create. This will be recorded. So Snowflake ID not new. The generator should work independently. It shouldn't be the issue. It's not a blocking issue. So new queue manager. Is it a blocking issue? I don't think it's a blocking issue, but the register can be a blocking issue. But if error occurs in register, we should have seen it. New registry, handler.new registry. What does new registry do? It only creates an in-memory map, so it should not be a blocking issue. Register. Can this be a blocking issue? But it is also not creating a new retry engine. Okay, it gives us a retry engine. It takes a job, which we give as job store. Max delay, time dot duration of cfg dot max delay, and a DLQ store, which is this. So worker pool dot new worker pool context dot background. So new worker pool takes a context, a job store, a registry, a retry engine, and num workers. That is looking good to me. Start the worker pool. We are adding the main queue and starting. Then we call the new server. New server takes a queue manager, Snowflake ID generator, and DLQ store, queue factory, and a registrar, which is an interface, small server in a goroutine. So if this fails, log.println can't start HTTP server, we should have done signal. Why is this failing? Where in this part is this failing? Why is my Redis-based implementation not reaching? Here. So while it's working, I should also check, is there an issue with config? I'm converting config into this, and I'm giving it a minute, and then inside the terminal, what are the things to do? Starting to server.go. actually the issue? Let's see one thing. One thing we added was add queue. What does add queue do? Add queue internally. It's a lock, appends to the queue, and makes the worker. Here it blocks, I think. But if it blocks, yep, it blocks here. I think it blocks here. If notifier will not fire notification, we get a notifier. Notification. I think it blocks here. This is the issue. In the memory based part, this was not blocking because of add queue was not getting a queue dot notifications implementation. But in the Redis part, we are getting queue dot notifications implementation. So add queue blocks the transaction. What is this? In Redis blocks up before the print. In Redis mode, main calls worker.addQ and that synchronously subscribes to Redis pub-sub. Does a blocking? Yep, this is the issue. So if pub-sub connection head 6 times unreachable Redis, auth ACL issue, network stall, the main go routine never reaches the fmt.started see the call in main.go. Yep, that's what I got. Add a timeout around pub-sub.receive, for example, context with timeout, receive timeout. So add queue returns even if Redis is slow, unreachable. Move the subscription into a go routine so startup can continue even if pub-sub is delayed. Ooh, I need the pub-sub to be done after server initiation. What if I add queue after server initiation? Add a timeout on pub-sub.receive. Pub-sub will only work if queue has been implemented. Pub-sub will only work. This is blocking safeguard. Pick one. Add a timeout. What should I do? Worker pool.add queue and the worker pool.start. Can I start without adding a worker queue? Without adding a queue here and add the queue after like here. Can this be done? What does it do? Queue manager, API Snowflake, queue factory, worker pool. So pub-sub dot receive. Should I add a time of move the subscription into a go routine so startup can continue even if pub-sub is delayed? Pub-sub is delayed. This one looks good to me. For now, move the. But I don't want it to be an go routine. I want it to be in synchronous way. This is the blocking part. So we have to do something about it. Subscribe notification. What it does is when it context subscribe, not subscribe. So it needs Redis queue dot notify context. Your Redis queue dot notify key is first it needs a Redis queue to work. The main queue is the Redis queue, isn't it? The main queue here is a Redis queue. Main queue is a Redis queue. Why it stalls? That's the main issue. Before implementing solution, let's discuss why it stalls. That would be much better. If I understand why it stalls, then I can give it pause blocks waiting for subscription completion, which shows in block firewall and there's a TLS or mismatch even if ping succeeds earlier. Since ping and separate connections. Next, I will ask environment. What it is otherwise retry engine. So what I can do is start the buffer tool, start the HTTP server, yes, so that to shut down. It stalls that print because Redis path blocks in worker foo.add queue. In Redis mode, add queue. Redax notifications and false subscribe notification, which does the blocking for sub.receive context to wait information. If that information never arrives, add queue never returns, so you never reach the fmt.print line. That I understand. Why that receive might hang? That's the main question. Redis pub sub connections can't be established. DNS, firewall, container, network wrong or host for even if ping on the normal command connection succeed or TLS mismatch and PubSub connection. So manage ready setup here. PubSub block via proxy or manage service tier ready to be overloaded or paused so it does never sends the subscription act. Two quick questions. Do you see moving Redis backend log and then nothing with no error? Yes, I see using the Redis backend, Redis based backend, and then nothing. Okay, with no error. Are you on local Redis or a managed node? I'm on local Redis. So local Redis. Was it because I flush on? This was likely because the subscriber is not doing this. Due to stalled Redis connection, a client working on a cancelled context. Should I restart my Redis assistant once more? So system CTL restart Redis, not Redis. It should not be restart like this. Sudo system CTL system CTL status Redis. It is active, it is running. Let me create this one. Given the using Redis backend to run client.link to blocking calling it no time out. It waits for the subscribe act. If the act never arrives, connection ends. It is not listening. Add queue. That interface never returns and your print never executes. Local Redis the most common popular Redis URL partition. Local host versus 1.7. Well, the app launch except Redis URL that is Redis CLI. Let's use Redis CLI. What was the command it told me to use? Redis CLI -u and our Redis and what I need next is ping. Let's ping it. Oh, we should be Redis CLI form. It returns form, so it's working fine. Is Redis running at a system service or in a Docker? In where is the it? One thing to know. I flushed Redis before test. Would that be an issue? Flush doesn't affect it, so this won't be an issue. Checks for a network issue. Let's try once more. Using Redis-based backend. Why it blocks on add queue? I need the add queue function to be much better. It shouldn't block here. If it blocks here, then it's a issue. We got a subscribe notification pool dot context. Okay. Checks the queue. Let's check. Redis URL is subscribe GoTaskQ notification notify report. See. Deadlock or stall inside core Redis connection despite external Redis connectivities checks. So this can be a here we are having a mutex lock. Okay, here we are unlocking the mutex. Here we are having a mutex lock, and here we are unlocking the mutex. But does subscribe notification have a mutex? Subscribe notification. The notifications. I need to check it. Q.go, Redis.go, lastly. Does it have a mutex? It's not a mutex issue, I think. Not a mutex issue. This all happened when the Redis implementation. Let's try. Install is encoded by Redis flush or pub sub and check. Make sure it's the control flow bug in the worker code. Add queue calls, subscribe notifications, and then run forward notifications synchronously. Oh shit. Tool.forward notification. Add forward notification, which blocks forever waiting on the notification channel or the context. Yep, it blocks here. That means the main goroutine never returns from add queue. So it never reaches. This only happens when the queue implements notification. If that matches what you are saying, we can fix it. The blocking loop is we can make it go full forward notification and let's check it out. Let's see. Now whatever we need to go build and go task queue, and now it's working fine. This was the main issue. It was blocking because of we were calling it synchronously and it was blocking the main thread. So that was the issue. Let's try everything now. Curl. We will check firstly the queue we have, the next queue for q/xyz. Curl, we need to post request this success creating a new queue. No issues here. Let's get the queue names. We have a queue. Next thing we need to do is we have to have a curl request to create some jobs. First job will be for normal for XYZ queue, it should work now, and it works without any issue. And the second job will be normal for default queue, and it worked fine. So it's not the issue, and the job done. Everything working fine. Let's check the metrics. Curl HTTP. Okay, we have the metrics here. Let's maximize this. So the metrics we have are seconds bucket. Default queue has a own bucket. QXYZ has a own bucket, and job duration seconds count 1. Jobs and queue, total number of jobs and queue is 1 in the default queue and 1 in the XYZ queue. That's alright. Processed, total number of jobs processed. 1 processed from this and 1 processed from that, and that's done. And queue depth, current queue depth is 0. This is 0. And GoTaskQ active workers, that's 100, because we have 100 active workers working on multiple queues using our. So we can say that our round robin scheduling is working fine. Okay, for that, let's test it. Create a stress test. Last time I used for the stress test. I should just check it out. Benchmark. It was here. So create a stress test. Create a stress test. It should create a stress test using A to check multi-queue ability. So let's check the multi-queue ability here and see how it goes. Let me give some context. I'll create a bash script that I'll create a directory for test, then I'll update the test, and this will be infrastructure and convention. Let's test the system. Accepting. The stress test will tell us if our round robin is working fine or not. Alright. Also, we need to test our round robin architecture. So I'll need to have a test there. I will also add benchmarkings here in the test, but for now, a stress test is enough. The multi-queue functionality is okay, and planning to update the user and sample position benchmark session. Sets configurable. What is the script? Let's see the script. It's writing the script. Okay. So what is the script it created? Okay. Let's see what the script is. If there is no command, hey devel echo hey is required, install from this. Okay, we don't have hey, then base URL is this. Queue count 3, request 50,000, concurrency 200, queue prefix stress, queue suffix is empty. So it's creating a job type logger, payload message stress, priority 5, next retry 0, check matrix 1, queue count equals to this, queue count must be a positive integer. Okay, second for a positive integer. Suffix equals to this. Q suffix, it will add a Q suffix. Q suffix, then Q suffix. Q is equal to this. So it will add suffix to the queues, existing queues, base URL. HTTP codes post base URL. It will create queues here, and then it will check concurrency. Check metrics. It will check the enqueued and the processed. Let's go. This looks good to me. If there is failed, when our mole here failed, we created a. Let's run it. What of question why it is not needed? I'll mention the respect addition in a bit. Oh, whoa, 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 whoa! Stop! I'll run it. So what I'll do is cd to scripts and let's sh stress multi-q.sh. What it should do is it should spawn a lot of jobs that it will ready, and a lot of jobs will spawn a lot of queues. What is done is okay. The total it took 12 seconds. Okay, let's go. For first, it took 12.53 seconds. There was this much data transferred. Response time histogram shows 0.550. 99% latency. It's 0.06 at 9. Status code. All responses were okay. Coming to the next, we got 0.0702, and all responses were okay. And lastly, for the last, 0.0699. So I can say the average time for %99 P99 is percentile 99 is 0.69 something ish or 0.7 ish, 0.07. So metrics I have short. We got GoTaskQ logger stress 1, we got 50,000. Stress 1 status done. What the hell? Okay, it should have been processing right now. So I need to do something. I need to check. I think it is being processed. Now everything, I think everything has been processed. And let's see. There should be 50,000 enqueued total, enqueued total, job processed total. There should be 50,000 for each. 50,000, 50,000, 50,000. And that's all we need. So our queue is working flawlessly without any issues. Our round robin scheduling is working fine. I'll post this as version 1.1 with multi-queue support, and let's call it a day. Thanks for watching. Let's meet tomorrow. In tomorrow's stream, what I'll do is I'll create a library out of this. Okay.